Hey everyone, here's another example from section 2.2, finding a limit as t approaches 11 for this function. First thing we're going to do is we're going to check to see if this function is going to, if we can evaluate this function at 11. If you plug in 11 and you square it, 11 squared is going to give you 121. 121 minus 121 is going to be 0. So you'll end up dividing by 0. So this we can't start out with our normal methods here, which is just plugging in 11. We need to actually then go through and see if we can do some factoring in this and canceling so that we can make this denominator actually not give us a domain error, not be something that's undefined. So I'm going to start out by saying let's take this here and we'll say t squared, so limit as t goes to 11, we'll say t squared plus 3t minus 154 over t squared minus 121. So they're kind of testing your factoring skills here. And what they're going to do is they're wanting you to break this up into two different sets of binomials. So on the top one, we know we got to have t here and t here. The bottom one will have t here and t here. So let's go through the top one first. I need two numbers that are factors of 154 that multiply to be negative 154, but add to be 3t. So I did this actually, I kind of cheated beforehand, but in my calculator I just quickly went through and I divided some stuff out, and I found that some factors of negative 154 are 14 and negative 11. So we're going to write down plus 14 here and then minus 11. And you can see that the difference between 14 and 11 is 3. So 14t minus 11t still gives me that 3t when I add them. But if I multiply those, I get negative 154. Now on the bottom part, 121, we know that's 11 times 11. Well, if I want that to be negative, one of them has to be negative. So I'm going to say plus 11 minus 11. And you can tell negative 11t, 11t, that'll cancel out, which is where we get the 0t from. So these are the factored versions of these two quadratics. The t minus 11s then you can see will cancel. And now we're in business because when we plug 11 in here, we don't have that domain error anymore. So we can say that t plus 14 over t plus 11. We'll plug in the 11, so we get 11 plus 14 all over 11 plus 11. That's going to give 25 over 22. So our limit as t approaches 11 for this function is 25 over 22.